Hello everyone, let's take a look at LeetCode 489, Robot Room Cleaner. Since it's a log question, so let's take a look at problem description first. Given a robot cleaner in a room modeled as a grid, so each cell in the grid can be empty or blocked. So robot cleaner with 4 given APIs can move forward, turn left or turn right, and each turn it made is 90 degrees. When you try to move into a block cell, its bumper sensor detects the obstacle and it stays on the current cell. So we need to design an algorithm to clean the entire room using these 4 given APIs shown below. So the first API is move. It returns true if next cell is open and robots move into the cell. And it returns false if next cell is obstacle and the robot will stay on the current cell. And we have turn left and turn right function. Okay, in theory, we only need one function, and one is enough. And the last API is clean the current cell. And for this problem, there are some notes. If the input is only given to initialize the room and the robot position internally, we must solve this problem blindfolded. Like in other words, we must control the robot using only the mentioned 4 APIs. So we don't know the room layout and we don't know the initial robot position. And the initial position will always be in an accessible cell. And the initial direction will be facing up. And all accessible cells are connected, which means that as long as it's not blocked, there's a way to clean up that cell. And we need to assume that all 4 edges of the grid are all surrounded by wall. So for this problem, we don't know like how big the room is. It's like a 2-dimensional matrix, but we don't know how big the matrix is, and we don't know the start position. But we do know like we have a robot, and the robot is placed at the initial position, but we just don't know like the coordinate. But it's fine. We can assign the initial position any value, right? We can make 0, 0, or we can make it 1000, 1000. It doesn't matter. Okay, so let's take a look at like how can we solve this problem. Okay, for this problem, the initial idea is that we shall use DFS since we only have one movable machine, right? And also we can discuss randomize the solution with the interviews if we implemented the DFS first. Like after we implementing the DFS solution, we can discuss more some randomized solutions. Okay, let's use a simple example to show how the solution look like, assuming the grid is like 2 multiply 2. And this cell is blocked. And assuming this is the initial position of the robot and it's facing up, right? So facing up, I define the direction is 0. 1 is right, 2 is down, 3 is left. Okay, and we also need to have a data structure, maybe something like a hash set or set to record the visited cells. Okay, and like previously, like if we want to do a DFS in a 2-dimensional matrix, we need to visit 4 directions. So we have this directions array. So if direction is 0, so we go up. If direction is 1, we go right. If direction is 2, we go down. If direction is 3, we go left. Okay, at first, we just clean up the room and add current position to visited. I initialize the current position like to 0, 0. So I insert 0, 0 to visited and we clean the current cell. Okay, next I want to try 4 directions, right? So first we try the up direction. But we tried move but failed since move function will return false. It's blocked, it's a wall. Next, I turn right, I try the right position. Yeah, it works. So we move to right and current position is 0, 1. Okay, now we are in a new cell, so we need to clean the new cell and we need to add the new position. like to visit. Now we want, in this new cell, we want to try 4 different directions, right? So first, we want to try direction 1. So we'll try to move right, but it's a wall, so move return false. Then we turn right, and we want to try down, but it's blocked, so move will return false. Then we turn right, we want to try the left direction, but the left cell is visited, so we can track the visited set. It's visited, so we just skip it. Then we turn right, and we want to try the up direction. Up is -1, 0, so we want to try this cell. This cell is not visited, but move will return false since it's a wall. So finally, we turn right. You may have noticed that now we finish visiting the 4 directions, and the direction is point to right. It's the same as like when we goes into this new cell, right? So at the beginning, it's facing right. At the end, it's also facing right. Now I finished the processing this cell, so I need to go back to the previous state, like this. How can we like restore our initial state? First, we can call turn right twice, like this. Next, we can call move. Next, we call turn right twice again. Then, like we restored our previous state, right? Okay. Next, for this cell, I want to try next direction. So direction become 2. Okay, then I try to move. Yeah. So this cell is not visited and move return true. So we are now at this cell. So we need to clean the room, and we need to add the position 1, 0 to visited. But next, we are in this cell. We want to try 4 different directions. So we first try down, but failed. Try left, failed. Then for up, since this cell is already visited, so we skip it. Then we try right, but it's blocked, so move return false. Then we're facing down again. It's same as like when we go into this new cell, right? After turn right 4 times, we turn down, like it's facing down again. So like previous, like we need to turn right twice, then call move, then turn right twice again. So we restore the previous state. Okay, so we are here again. Then we need to call turn right. Then we try to move left, but failed. Then we turn right. So it's in the initial state, and the recursive function finished. And at this point, we have already cleaned up all the cells, all the accessible cells. Okay, let's take a look at how to implement it. So in our main function, we have a visited and set. And in my DFS function, I pass robot, pass visited. Of course, we need to pass by reference. And I initialize my robot position as 0, 0. It doesn't matter to use one number, 1000, 2000, they all work. As long as you can indicate your current location, you can mark your current location. And initially, the robot is facing thing up, so direction is 0. Okay, at first, we just clean the cell and insert the current position to visited set. Okay, next, we know we have 4 directions: up, right, down, left. Now I just try my 4 different directions, and I can get a new I and new J for set directions. And we know, like in this blocked code, I will try to like move and DFS call. And at the end, we will just like turn right and update our direction for my current, right, for my current cell. So in this block, for this new position, if it has not been visited yet, and robot can move into that position, we will try to do the DFS call that, like use DFS to clean up that cell. So we will call DFS pass robot, pass visited, pass a new position, and pass our direction. So for this new cell, we will recursively and process that cell. After processing, we know we need to restore our previous state. So we need to turn right twice, then move, then turn right twice again. Okay, so that's basically all the implementation. And after the DFS solution, we may discuss with interviews about maybe randomized solutions. Okay, that's it. See you next time.